Okay, hi everyone, good afternoon. Finally, we can start. Sorry for a short delay. So today we are hosting Filip Piotrowski, who is the master student from our department, and he will be discussing the results he obtained in his bachelor thesis. Yes, am I right?
Yes.
Yes. So I will share the screen and just welcome Filip to the presentation. So the rules, as usual, after the presentation, all of you will have a chance to ask the question or give some suggestion to Filip. So floor is yours. Welcome.
Thank you. Hello everyone. So today's topic of our seminar is public transport accessibility. I will introduce some theoretical framework for the concept of accessibility. I will tell how to connect accessibility, which is a topic from transport geography, I would say, with regional science or economics. I will provide some, I would say, technical details how to deal with transportation data. And then we will proceed to a case study, which was the topic of my bachelor's thesis, which is accessibility, public transport accessibility in the Warsaw metropolitan area. We will go through results, and yes, and that's the outline of today's seminar. So firstly, theoretical framework. Maybe it's good to start with a definition. What is accessibility? And the most classic definition is from 1959. It is a potential of opportunities for interaction. Second definition, similar, inherent characteristic or advantage of a place with respect to overcoming some form of spatially operating source of friction. For example, time and/or distance, or the extent to which the land-use transport system enables individuals or goods to reach activities or destinations by means of transport modes. So in this definition, we see that accessibility consists of two main components. The first one is cost of travel. So the further our destination is, the more eager we are to travel there. And the second component is quality of opportunities, which is what motivation we have to travel to certain destination, whether it is shop, school, or hospital. And to capture those two components, several types of measures were constructed. The first one, cumulative opportunities measures, are the simplest one. They count number of opportunities reached within a given travel time or distance. So, for example, we are here at WNUW, and we want to count how many shops are in the radius of 15 minutes walk, or some very trendy topic today. So 15 minutes city, that's cumulative opportunities measures. The second one, more advanced, I would say, is gravity-based measures, and this measure weights opportunities by travel cost function. So we don't have a cutoff point of, for example, 15 minutes, but we take into account that the our willingness to travel declines towards zero with time or distance. And the third one, utility-based measures. In fact, I don't know a lot of about them, but they are based on random utility theories or some models of discrete choice. So why do we choose this certain, I don't know, shop, school, or not something else? But in this seminar today, we are going to focus on gravity-based measures. So what's the basic formula of the gravity-based measure? It's like in Newtonian physics, I would say. So there are the accessibility at point I is defined as a sum of all destinations, and they are represented by a little a, which is attractiveness of destination. This is a sum, and it's weighted with travel time between an origin and destination. Yes, so these are the two components. A is a sort of quality of destination, and this T is declining willingness to travel. And the distance or time is put into impedance function. And as I said, it represents the resistance or effort associated with traveling between points. And in urban reality, it is more common to use time as the measure of distance, because we all know that in a city, 2 points that are not far away from each other might take a lot of time to travel between them. So time is more common measure here. Okay, and so I told about the impedance function a little bit, and how about attractiveness? How to measure it? What can it be? The simplest idea behind it is population density. Why? Because population density correlates with economic activity and the different facilities, like mentioned before. So it is a simplest and quite safe measure of attractiveness of destination. More advanced is economic or employment-based measures. So some region is more attractive to travel if the wages are higher, if there are more firms that are hiring in this region, or there are more businesses inside. Or also popular in this to measure attractiveness is service and amenities number. So it's simply number of shops, healthcare facilities, schools, or we can also use land use measures to also to capture some sort of proxy variable for economic activity. So now let's talk about the impedance function. It represents the difficulty of reaching destinations and reflects commuters' travel preferences. And its parameters should be carefully chosen, because the whole measure of accessibility depends a lot on the choice of parameters. So they should be estimated based on some empirical data. And the most common formulations of the impedance function, also known as time decay function, because our time we want to travel decays with time. So the first one is simply exponential function. Also, we have Gaussian function, which differs only in the square of distance inside, or step function. And they are visualized on the next slide. So we can see that if we take the step function, in fact, what we get is the cumulative accessibility measure, so that how in this example, how many opportunities are within the reach of 25 minutes. And now we proceed to a situation, because sometimes these areas are quite small, but it might happen that we calculate accessibility for some bigger areas, so that there is possibility that a significant amount of destinations are inside the area. So to take into account that some passengers may want to travel internally, so they also have access to destinations inside the area. Some literature proposes self-potential of origin, and it is calculated as follows. So let's look at the picture on the right-hand side. Let's say that the blue polygon is our area. We take a circle that has the same area that the polygon, and we calculate the radius of that circle. So that approximates the size of our area, and it is this radius is multiplied by some constant, in this case 0.5. I should have put simply a letter for a constant, but never mind. And so this formula above stands for radius, and from the law of physics we know that the formula for time will be radius divided by average speed inside average speed of commuting inside the region. And when we have this internal travel time, we can put it into the decay function and add it to the accessibility measure. And what we can also account for in the gravity model is demand, because let's imagine a situation where we have a hospital in the nearest neighborhood. So we may say that it is our accessibility to healthcare is high. But if many surroundings, individuals from many surroundings wants to get also to this the same hospital, our accessibility declines, because the individuals compete for the service. So literature suggests that we should also consider the competition for opportunities, and this adjusted formula is just the old formula, and it is divided by demand, also weighted with distance. So when we so I sort of draw the main theoretical framework for our today's topic, and now we will talk about what's the possible applications of accessibility in regional science and in economics. It can be useful tool for describing regional economic growth, because higher accessibility means means simply better accessibility to services, goods, and jobs, so that it can boost the economic growth of a given region. Furthermore, we can use accessibility to measure social equity, or to assess social equity and inclusion, to see whether some regions are excluded, and maybe it slows down their economic growth, or generates some problems. Accessibility can be also used to describe property value, because many times in the advertisements we can see that that a flat is I don't know, 15 minutes from a subway, or something like that. So we can also intuitively suspect that accessibility to public transport is maybe quite important to think when valuing the properties. And it can be simply a tool for assessing the transport network and planning some improvements. I know that in the London metropolitan area, they have their own measure, a little bit different from the gravity model, and they apply it to assess the performance of their public transport system. Okay, so now let's head to the case study. I choose to analyze the Warsaw metropolitan area because I know its public transport system well. Okay, so I decided to analyze, we call it here obważanek, which is simply the neighboring counties next to Warsaw. And why this area? Because I took into account three main public transport providers, which is ZTM, the regular public transport like trams and metro and etc. Koleje Mazowieckie, which are a regional railway, railway, and WKD, which is also, it is called narrow gauge trains. Yeah, it's on the south west of Warsaw. So I simply decided to choose the area of operation of this of these providers. Okay, so how did I acquire the data for my work? First of all, destination attractiveness. I chose the simplest model, in which attractiveness is simply population density, and we are in quite good position that in 2021 there was a national census, and it it showed the population density in 1 kilometer grid, impedance function, and here I had to take a look at passengers' behavior, and also to do it, I take a look at Warsaw Transport Survey 2015. It was a survey. It is every 10 years, so this year they are surveying people. And as far as I remember, there were 18,000 people asked, and they simply tell the interviewer what time they depart, what time they arrive at destination, what mode of transport they take. So having this data, I had a function of empirical function of the length of the travel. And the last component were travel times. So it was the most computationally expensive task to perform, because if we have n points, n regions, then we have then we have to calculate a matrix of travel times between those points. So the number of calculation is squared n, and it was a huge obstacle to overcome. And I will talk about it later in more technical parts. Okay, so we have population density, just to illustrate. Yes, and here is a visualization step by step how I calculated the accessibility. Let's say I want to calculate accessibility for the this central grid square, the red one. Firstly, I take centroids of the grid, and then I have to calculate the travel times between all those squares. Yes, and to make this travel time matrix, I took advantage from R5R package in R. And how does it work? It uses a GTFS. GTFS stands for General Transport Fit Specification. It is some widely used format for transportation data, and all major providers of public transport across the globe share their transportation data in this format. And for example, if we have some apps on the phone about planning routes of our transport of public transports, or some schedule viewers on Android or iPhones, and they are mostly based on this format. And the second component were OpenStreetMap, just to get the network of simply road network. Yes, this package allows to use different transport modes. So I set it to use only walking and transport and public transport, because I suppose that's the way people use public transport. So I didn't take into account some situation when, for example, a person picks up other person, and then takes metro or something like that. So I focused only on walking and then using transit and then walking to the destination from the bus stop or something. And the main advantage of this package is that it is quite fast. Even though the calculations are expensive, I tried several packages and some of them calculated this travel times for whole night, and they didn't finish. But that package was quite okay. Yes. So that's the flowchart of what I did in my research. Yes, nothing to add here, I think. So the results. Let's start from the assessment of the time decay functions. I didn't provide the table with this estimations, but just to visualize it, I chose the Gaussian function, and the color of the estimates are on the right, those betas, and I estimated the parameters for car for traveling by car and transit. Okay. Okay, so that's the main results of my of the research. This is simply the measure and the measure of accessibility, and with the green dots I indicated railway stops, just because we can see a pattern that even if the points are far away from the city, there are some radial pattern, I would say, that follows to the center of Warsaw, that with lines with higher accessibility, and it co-occurs with railway lines. So the conclusion from that map is that railways provide some sort of bridge from the surrounding communities to Warsaw. So, for example, some citizens living in Piaseczno or Legionowo have quite high accessibility compared to Warsaw. And what we can also see from the previous slide is that the intuition is that accessibility is somehow connected with travel time to the city center, is correlated. So here we can see the same, which here we can see the it is the measure of travel time to the city center. And if we take a look at it on the plot, we can see that the correlation between travel time to the city center and the accessibility index is higher than the correlation of accessibility index with population, with population density. So the conclusion here is that the accessibility is very centralized around the city center. So it is harder to get between between some suburban areas than between the suburban areas and the center. And what I also decided to compute is the gain of accessibility, because we may think that, okay, I computed accessibility, public transport accessibility, but for some very dense areas, the accessibility is high even when you're walking. So I computed accessibility the A walk, so the accessibility only when you are walking, and accessibility with public transport. And this index shows how much the existence of public transport increased the accessibility in relation when there are in relation to the situation when you have to only walk to the destinations. And the map shows corresponds more or less to the area of operation of public transport providers. Okay, this slide is in Polish, sorry for that, but I take it from another presentation, and I didn't have time to change it. But what we see here is a temporal temporal variations of accessibility. So I thought that if I can compute accessibility, it would be also valuable to see how it changes over time. So for each square grid, I computed accessibility in different hours, and here are the results. I think it is every 15 minutes or something. So I suppose that we are departing every 15 minutes and then measure how far we can, what's our accessibility. So what we can see here is that there are deviations between the accessibility level between Sunday, which is niedziela, this line, and this is a regular weekday. And we can see that the transport systems are designed that way that on the weekday they provide a very dense transport frequency in the rush hours, so the around 6 or 7 a.m. and then in the evening. But on the some off-peak hours like 10 o'clock, the frequency of service is lower. We can see it on the average and median plot. Okay. And we can see also here the hours of operation of public transport, so that around 4 o'clock it is the lowest from the midnight. Okay. And also it is, I thought it would be valuable to look at it in the temporal dimension. Here we have a relative standard deviation of accessibility in each grid square, and I took only into account the hours of operation of the transport network, so from 5 to 11 p.m. And what we can see is that the suburban areas have much worse and have a much higher variability of service. So the level of the frequency of public transport departure is varies across the day more on the the suburbs, and it means that it might suggest that the budget of public transport in these surrounding communities is lower, so that so that the transport operates more frequently only in those hours when it is needed. So which are morning and afternoon rush hours. Yes, and in the theoretical part, I introduced that self potential of accessibility and the correction for demand, because I also decided to compute accessibility to jobs by public transport. So the first formula is the same as the a few slides before, and the second one is just more advanced, but it just captures the fact that when other people want to use some facilities, only part of them travel by public transport, but they may also travel to the destination by car. Yes. So this alpha parameter I estimated also from the Warsaw Transport Survey. It is the share of commuters using public transport, and the other things are roughly the same. The destination attractiveness here is a number of jobs in a given municipality. It is estimated from the national census. And the demand potential is the population size of the municipality, which is yes, also from the census. Okay, that's more complicated graph of what was happening there. So I took advantage of the data on the flow of the commuter flow related to employment, also from the census. It is quite quite an interesting data set, and I visualize it on this plot, so we can see that the majority of employees in the surrounding communities work in Warsaw, because the lighter the line is, the bigger flow. Yes, and here we can see the similar map, which is share of employees working in Warsaw. So I placed it here because I would suggest that also here we can suspect that there will be some pattern, some radial pattern with very focused on the on Warsaw, and the results of the previous calculations. It takes it takes account for the self potential of those communities, but also the demand size. And what I want to highlight here is that the starting point from each communities are not just centroids, but they are weighted by population. So I suspected that it would be more reasonable to calculate distance from the points where most people live. Yes, and to take a look at this pattern, we have a scatter plot here. Share of workers commuting to Warsaw and public transport accessibility to jobs. So it shows that the higher it shows that that Warsaw is the main provider of employment to the surrounding communities, and it boosts the accessibility to jobs. And also we can see from the population size that more populated communities have generally more higher accessibility scores. Yes, and that's all for today. Thank you for your attention, and I hope that this I hope that this seminar maybe inspired you in some ways to use accessibility measures in your research, because I think it's useful. And if you have any questions, feel free to ask.